Okay, so again, we are solving linear inequalities, right? We have to find the x and y values that make this inequality true. Since there are so many answers, the only way to show all of them is on a graph. So basically, we will be graphing a line and then shading on one side of it. So if we're going to graph this line, we have to solve it for y. So now we're going to minus 12x's, right? That leaves us with negative 2y greater than, I can't combine them, so I'm going to put my negative 12x first, and then my plus 2. The only thing I have left to do is to divide everything by negative 2, which means you are dividing both sides of an inequality by a negative number. That means we have to flip that symbol. So it's going to be y, symbol flips around, negative 12 divided by negative 2 is positive 6 times x, and then positive 2 divided by negative 2 is negative 1. So now we're going to graph this line. We have a slope of 6, or think of it as 6 over 1, right? A rise and a run. And we have a y-intercept of negative 1. So we're going to go down 1 to our y-intercept, and then we're going to use slope to move. Rise over run. Positive 6 over positive 1 is up 6 and right 1. 1, 2, 3, 4, 5, 6, and right 1. Or we can go the other direction and go down 6 and left 1. Okay, probably the most annoying part is whether you want a dashed or a solid line. According to this problem, the answers are only the y values that are less than the points on this line. But I'm not allowed to equal the points on this line, which means the line purely acts as a boundary between our answers and our non-answers. But any point on the line is not included. So to show the points on the line are not included, we put a dashed line. Okay, so guys, the line cuts the graph in half. We now have this side of the line that we could shade on, or we have this side of the line that we could shade on. What does the problem ask for? It asks us to shade where y is less than that line, where y is below that line. Well, guys, the y values live on the y-axis. So your y-intercept cuts that y-axis in half. You now have y values getting bigger and bigger and bigger and bigger and bigger above your line on this side. And then you have y values getting smaller and smaller and smaller and smaller below your line on this side. So if they want y to be less, where y is below, that's on this side of the line. So any ordered pair that lands on this side of the line will make this inequality true. Do you guys feel okay with that? Everything's good? Okay. Like I said, guys at home, are you okay? It's usually not a bad topic. You guys are pretty darn good at graphing a line. It's usually just the shading that throws people off, which side to shade on. So if you're struggling with the shading, please let me know. Let me try and help you, okay? All right, let me do the problems from yesterday's notes, and then we're basically done. I just want to talk about the homework shortly. All right, so these were the last two problems on yesterday's notes that we didn't do. So guys, remember, a straight line can do four things. It can slant to the right when the slope is positive. It can slant to the left when the slope is negative. But it can also be horizontal when the slope is 0 because there's no change in the y-coordinate. Or it can be a vertical line straight up and down when the slope is undefined because there's no change in the x-coordinate. So I warned you guys, you should know you're looking at the equation of a horizontal or vertical line because their equations only have one variable in them. So when you get to example 4 and you have to graph this solution set, you should be looking to solve it for y. But there is no y. The only variable here is x, which means we're going to have to solve it for x because it's the only variable in this inequality. But it also means it's going to be a special kind of line. It's either going to be horizontal or vertical. So let's solve it for x. Minus 1, negative 2x is less than 8. Divide both sides by negative 2, which means you've just divided both sides of an inequality by a negative number. We're going to have to flip that symbol. X, symbol flips, negative 4. Okay. Well, guys, I don't know if you remember, but normally you've worked with this kind of inequality before, except you would have graphed it on a number line, right? You would have went to where x is negative 4, open circle, shade to the right. The problem is, right now we are working with linear inequalities on a two-dimensional space. We are working on a two-dimensional space, which means we have to think of this as the line x equals -4, and then we'll shade on one side of it. We can no longer think of it as shading on just a number line. We are working on a two-dimensional space. Okay, so guys, let's graph this line. X equals -4. What kind of line was formed when every single x coordinate had to be -4? Well, first, go to your coordinate plane where x is -4. Where is x -4? Right, left, up, down? It's left 4 spaces. So what kind of straight line is going to be formed when every single x coordinate on this line has to equal -4? Well, guys, that means I can't go right or left because that would change the x coordinate. But I can go up or I can go down because all of those points still have an x coordinate of -4. So what kind of line is formed? A vertical one. However, do you want solid or dashed? I only want the x values on this graph that are greater than -4, but not equal to -4. So that means I want to use a dashed line to show that it's a boundary, but we're not including -4. So it's a nice dashed vertical line. But guys, it's a line. You still have 2 sides. You're either going to shade on this side or you're going to shade on this side. We want the x values that are greater than -4. So where are the x's greater than -4? On his left side or on his right side? On the right side. So any ordered pair that lands on the right side of this vertical line is a solution to our inequality. Everybody okay? Good? Okay. All right, last one. Same idea. We come to this inequality, we have to solve it by showing its graph, right? Well, you go to solve for y normally, but you should notice that y is the only variable. There's no x. So it's going to be, again, a special kind of straight line. So let's solve for y. Add 2. 3y is greater than or equal to -15. All right, all you got to do is divide both sides by 3. Which means you just divided both sides of an inequality by a positive number, so absolutely no reason to flip. So y symbol stays -5. So now our job is to show all the solutions to y being greater than or equal to -5 on a two-dimensional space. So again, think of it as graphing the line y equals -5. Where would that line have been? Where is the line y equals -5? Where would y be -5? Right, left, up, down, down 5. What kind of line is formed when every single y coordinate has to be -5? Well, that would mean I can't move up or down because that would change the y coordinate. But I can move to the right and I can move to the left because all of those still have a y coordinate of -5. So it's forming that nice horizontal line. Do I want solid or dashed? They're saying that y can be greater than or equal to -5. Since it can equal -5, we use a nice solid line to say that he's included as a solution. And then again, a line will always cut something in half. So we should have 2 sides. We have the side up here above it, or we have the side down here below it. If I want y to be greater than -5, where do I want to shade? Where y is above -5 or below -5? Above. So any ordered pair that lands above this line is a solution to our inequality. How do you guys feel? Everybody's good here? Okay. Again, I hope this feels simple. The graphing part is usually great. It's like I said, it's the shading that worries me. Is everybody at home okay? Do you have questions for me? All right, then the only thing I want to do is just show you something on your homework to hopefully avoid you guys from getting anything wrong. So let me just bring up a homework question and we're done. Sorry.
I was going to say, I'll click it if it's graphing.
I didn't know I'd be able to describe it exactly where it was. So.
We'll have this math the same during virtual.
No, it's not.
I feel like I'm just like,
No, I feel that. I don't know what to do at the time. All right, guys, let me just show you. I know it's probably gonna be a little bit harder for you guys to see because I can't make it any bigger than this, but this is what a homework problem is gonna look like. So they give you an inequality, but it's multiple choice. So all you have to do is pick the correct graph. So hopefully, the first thing I want you guys to do is, guys, rule out ones that you know can't be the answer. For example, this is the inequality y is less than or equal to 7/3 x minus 2. The slope is positive. So get rid of any line that slants to the left. We know positive sloping lines don't slant left. So C is out. We also know they're asking for y to be less than or equal to, which means the line has to be solid. So get rid of any dashed line. So you know it's not C and D. So literally your answer becomes between A and B. So get that ruled out right away. Now, hold on, I can't move. All right, now, the only thing I wanted to warn you guys about is when you go to like, look at your y-intercept, right? Where's it at -2 and whatnot? I need you guys to realize that the axes, and I believe it's almost every problem, they're counting by increments of 2. So 2, 4, 6, 2, 4, 6. So if you're trying to like count your own slope and you're counting 1, 2, 3, you're wrong. You're not counting in the same increment as they are. So if I'm you guys, add your own tick marks. 0, 1, 2, 3, 4, 5, 6. Just so that if you count your up 7, you're not like going up like too far for 7. You know, I don't want you guys to be way too far out and you're not counting your spaces correctly because the increments are counting by 2. Do you guys see that? All right. All right. Again, I just hated you. I didn't want you guys to ignore that and start counting like up 7, right 3, and you're not in the right spot. Okay. Is everybody at home okay? You see what I'm talking about? All right. All right, well, guys, I'm going to give you an option. You can hang out on the meet if you have any questions for us. You can hang out on the meet and get to work, or you are allowed to leave the meet and start working on your homework, whatever you prefer. All right, but we are here if you need any questions for us, okay? All right, well, have a good day if you're leaving. Thank you for coming. Otherwise, hang out and ask some questions.